Here's problem 520. The coefficient of kinetic friction between the surface and the larger block is 0.25, and the coefficient of kinetic friction between the surface and the smaller block is 0.4. If F is equal to 22 newtons and M is 1 kilogram in the figure, what is the magnitude of the acceleration of either block? So we have two blocks, mass 1 and mass 2. And mass 1 is 2 times 1, or 2 kilograms. Mass 2 is 3 kilograms. So let's go ahead and mark those. And we can calculate the frictional forces on each of these masses. One we're going to call it little f1, and the other one we'll call it little f2, working against the motion. Little f1 is equal to mu1 mass 1 g. Mu1 times the normal force, and that's going to be equal to 0.4 times 2 kilograms times 9.8, and that's equal to what? 7.84 newtons. And then for the frictional force 2, that's going to be equal to mu2 mass 2 g. That will be 0.25 times 3 kilograms times 9.8. And that is equal to 7.35 newtons. Alright, so these are the frictional forces working against our pushing force F. And everything's going to move together. Everything's connected. So let's try treating this as one big glob. Total mass of 5 kilograms. We've got this F force equal to 22 newtons pushing on it to the right. And then we have these two frictional forces, F1 and F2, working against the motion. And as a result of these three forces, we're going to ignore for the moment the normal force and the weight force, because those are transverse to the motion. We're going to have an acceleration to the right. So according to Newton's second law for this glob, we would have that the summation of all the forces in the x direction would be equal to the total mass times A, and that would be equal to F minus little f1 minus little f2, the net force in that direction. So we have 5 kilograms times A is equal to 22 newtons minus 7.84 newtons minus 7.35 newtons. So A is going to equal 22 minus 7.84 minus 7.35 is 6.81 divided by 5, and that's going to be equal to 1.36 meters per second squared. And that will be the acceleration of both blocks. 1.36 times 1.36 meters per second squared, because they're both connected, they're both moving together, and so 1.36 meters per second squared is the acceleration.